Hello and welcome to our Checkpoint 1 presentation for data screening and descriptive analytics for our group project for Stat 512. Our group is a group consisting of myself, Avery Fry, Brittany Greer, Philip Goldberg, Caleb Day, and Su-Yan Cheng. So first off, we want to just do a little introduction to our data, the variables in there, sample size, and the result of some of the cleaning that we will get into next. So first off, we have 5 columns, 5 variables. We have one dependent variable, our Y variable, which is crimes per population. This is just a measure of the number of crimes reported per 100,000 population. We then have 4 independent variables, X variables, that we'll use to recreate the study done in the research paper given. These are all percentages. So we have percent not high school grad, which is just an indicator of the education level of the people in this area. These are all specifically pertaining to metropolitan areas. The next is percent unemployed. So that's the percentage of people that are not employed in this area, and those actively seeking work that aren't employed, which is a good caveat. Um, all of these are percentages are scaled so that the size of the area does not affect it. Just like the next one, which is percent pop under POV, which is percent of the population under the poverty line. And then lastly, we have another percentage, which comes from the LEMAS data set, which is what that LEMAS at the beginning is. And it's the percentage of police that are on patrol in the area. Some other important information for this step, we had 0 missing values after cleaning, and our sample size after cleaning and removing missing values is 266.
Hello, we're Group 12. My name is Brittany, and we're going to be examining the role of poverty, unemployment, education, and policing effectiveness in shaping urban crime rates across the United States. We're using the Communities and Crimes dataset and its related socioeconomic indicators to replicate and extend the analysis in factors influencing crime rates and econometric analysis approach. Our independent variables are school dropout percentage, unemployment percentage, below poverty percentage, and law enforcement personnel to arrest percentage, and our dependent variable is urban crime per 100K population. So for cleaning the dataset, I started off with looking at a list of the column names to figure out which ones we want to use. We aim to find variables that best match the ones used in the reference paper. So I started with limiting the dataset to only contain rows for which the percent urban column had 100%, since we're specifically investigating urban crime rates. For school dropout percentage, we're using the column percent not high school grad. For unemployment percentage, we're using percent unemployed. For below poverty percentage, we're using percent population under poverty, and for law enforcement personnel to arrest percentage, we're using LEMAS percent police on patrol. Finally, for urban crime per 100K population, we're using an addition of the columns violent crimes per population and nonviolent per population to create a total crimes per population column. So these are the 5 variables that we will be using moving forward. I created a new dataset with just these 5 columns, and I dropped any rows that contained an NA value, which resulted in our final clean dataset. I also did the descriptive statistics on the variable crimes per population, which is the number of crimes per 100K population. The median was 7,817, and the mean was 8,119. The mean being slightly higher than the median indicates that the data is slightly right skewed. The max was 18,508, and the min was 1,848, which makes the range 16,660. And the standard deviation was 3,122, so the data seems to be fairly spread out. I also made a box plot of the data, and it was slightly skewed right with 3 high outliers, but they were basically just above the upper fence, so I didn't think that they were too high that I thought that they shouldn't be included.
Moving on to the relationship between crimes per 100,000 population and percentage unemployed. Looking at the R output of the clean dataset, the table of values can be read and many descriptive statistics can be analyzed and interpreted from the data using the summary of the dataset. The mean percentage unemployed is found to be about 7.058%, with a median lower at 6.570%. The median being lower can imply that looking at just percentage unemployed, many of the outliers comparing the mean and the median will be at higher percentages. The range of percentage unemployed is taken with the minimum and maximum values and the difference between them coming out to 13.72%. And the interquartile range range is taken from the difference between the third quartile and the first quartile, coming out to about 3.4%. More descriptive statistics of variability can also be calculated. The standard deviation of percentage unemployed is found to be about 2.505%, and the variance of percentage unemployed is taken with the squared of the standard deviation to 6.273%. Looking at the correlation of the R output, it's found to be about 0.415. This implies that there's a fairly weak linear relationship between the percentage unemployed and the crimes per 100K population, but there still is a positive linear relationship between these two data sets. This can be found when looking at the scatter plot. Looking at the scatter plot of the R output, there is a modeled noticeable linear positive trend, but there are several outliers and data points that are drastically both above and below the modeled linear range. There also are not many data points to be found in the higher ranges of percentage unemployed, which could have variation in how the data is being analyzed.
The next variable we want to review is the percent population under the poverty line. So this measures the percentage of the population that is living below the poverty line. We can look on the left and see pretty clearly that this seems to have a positive relationship with our target variable. This is confirmed in our descriptive statistics. The correlation with the target variable is 0.63, which is a pretty strong, not the strongest, but a decently strong positive relationship. Some few other descriptive statistics on this one. The mean is 15.03%. The median is 15.21%. We have a standard deviation of 7.38. The minimum percent of the population under the poverty line is 2.27%. And the maximum percent of the population under the poverty line is 43.86%.
Hi, this is Soo-Yeon, and I will give you the summary of the case study I was in charge of. So the data sets that I have used as the explanatory variable, X is the crime rate, and the response variable, Y, is the school dropout percentage, noted as the percentage not high school grad. And then the overall purpose of this study is to try to correlate school disengagement with crime rates. So the data cleaning steps were done through stripping out the columns of the original raw data sets, and the outliers were observed through QQ plots, and in the plots they showed no missing values in both the crime rate percentages over here and the school dropout percentages over here. However, there are some deviations at the tail near absolute -1, 2, 1, and 2 values, and this shows that the data fit deviates from a normal curve. And in this case, like the curves bend upwards, indicating that there are some outliers in the extreme regions. So for the X values, the mean of the school dropout was 25.42%, the variance was 98.29%, and the range and the percentage ranged from 4.69 to a max of 55.72%. For the Y descriptor, the mean of the crime rate percentage was 8,119%. The variance was 974.7996%, and the percentages range from minimum 1848 to 18508%. And the correlation between X and Y was around 0.3116, which indicates that there is a correlation, but it's not a very strong one. 2 to 3 exploratory plots were plotted through histograms and box plots for the single variables of the school dropout and the crime rate percentage. So for the school dropout percentage, the histogram looks like this. The box plots look like this, with some outliers observed in the extreme regions. And for the histogram of the crime rate percentage, it also showed a little bit skewed normal curve, as well as a few outliers. So most high school dropouts were observed around 20 to 30% and shows a bit skewed data from the normal distributions, and the crime rates were observed around 8,000 to 9,000% and also showed a little bit of skewed data with missing values near extremes. Next, I made a linear regression between the school dropout percentage and urban crime using the LM function. So the results show that for every 1% increase in the school dropout rate, we have a 98.14 increase in units. Thus, we have a positive relationship between the x and y, and the p-values were very small, and that means this linear regression is statistically significant. The residual standard error is 2,972, which the model's predictions are off by about 2,972 crime rate units, and the coefficient of determination, which is r squared, explains the total variability in crime rate that is explained by the school drop rate, which is 9.7%. The F value is 28.39, and thus we reject that beta 1 equals 0, and thus the school dropout rate contributes to explaining the variability in crime rate.
Okay, so welcome. My name is Caleb Day. Me and my group has at this point already cleaned the data, and we each assign each other like a data, no, not data, a variable to each other to do like descriptive statistics, comparisons, plots, and all that random and all that fancy stuff. For me, I was given the one of the predictor variables, which is a law enforcement personnel to arrest percentage. And this is kind of like my short presentation on it. Jumping in directly into the descriptive data of it. I did this in RStudio where I did the descriptive summary on it. On the law enforcement personnel to arrest percentage, that predictor variable. And as you can see here, we have the 5 number summary plus the mean right there. So we can see, the range between 10.85 to 99.94. We can see the mean is about 86.88. The range is, 10 is already stated. The variance, which is 111.3195, which seems, pretty high range for, the X predictor variable, or in this case, the law enforcement personnel to arrest percentage, which seems pretty high. The correlation in this case is, well, pretty low, which is not really a good sign. What the correlation between the Y variable, which is like the urban crime right here, which is crimes per population, which is what it's called, and then the X predictor variable for meth, which is like law enforcement personnel to arrest percentage. The correlation between these two variables are pretty low. So like the urban crime, which is our like Y response variable, and then the like law enforcement personnel to arrest percentage correlation very low. And then we can then look at the plot. So this is the box plot and then the histogram. We see that there's several outliers here and there, and also it's very highly like skewed. So not a really good sign. So the see that there's not a whole lot of correlation, and it is very heavily skewed as we see in this graph. Well, these two graphs are like plots. So yeah, that's really about it. That's really about it for law enforcement personnel to arrest percentage.